So what we need to know for simplifying surds is if I'm multiplying or dividing within a surd, within a square root, I can split it up. So for example, if I had the square root of x times y, I could write that as the square root of x times by the square root of y. So I'm multiplying inside my surd, but then I can split it up into two separate surds multiplied together. I can do the same if I'm dividing. I can say the square root of x over y is equal to the square root of x over the square root of y. When this doesn't work is if I'm adding or subtracting. So it only works for multiplying and dividing. It's quite quick to see that it doesn't work for adding and subtracting. If I think about the square root of 3 squared plus 4 squared, well, if it did work for adding and subtracting, I could split it up and I could say the square root of 3 squared plus the square root of 4 squared, and that is equal to square root of 3 squared is 3, the square root of 4 squared is 4, and I get 3 plus 4 is 7. But we know that actually 3 squared is 9, 4 squared is 16, the square root of 9 plus 16 is the square root of 25, and that is 5. So we know that this is not true. This rule does not apply for adding and subtracting, only multiplying and dividing. When you'll meet this is normally when you've got something like simplify the square root of 12. The aim in this is to look for a square number that we can take out. So I can say that 12 is equal to 4 times 3, so I can replace that within my square root. Now I can use the fact that I'm multiplying, so I can split up my square root. And then because I know what the square root of 4 is, I can replace it with its square root, 2, and leave the 3, and therefore I get that root 12 is equal to 2 root 3.